Hi all, in this video I am covering the top 10 microservices interview questions specially asked at Deloitte and sourced from real interview experience shared by developer who are actually went through the Deloitte technical rounds. So Deloitte is one of the big four consulting firm and their microservices interview for 3 to 6 year experienced developer followed a specific pattern and they focuses heavily on Spring Cloud, distributed system designs, resilience pattern, and the cloud deployment. So, what these are the things they actually do on the client projects. So, for each questions, I will be giving you the exact question text and then walk through the 5 key points, and you need to cover in your answer. So each point has an label and online explanation, so you know what to say exactly. So let's get started. So before going ahead with the video, I request you to subscribe to the Developer YouTube channel where I share my real life uh, interview experience and I cover the different topics like Spring Boot, microservices, Java, and I also cover top most asked questions in different interviews. So let's get started. So first questions is what is the difference between monolithics and microservice architectures and when did you choose the microservices? Let me break down this properly. So most people say just microservices are better and this is not exactly correct. So point 1, monolithic architectures. So everything like UI, business logic, database access is packaged into one deployable units. So one var or the jar. It is simple to develop initially, but it's become a liability to at scale. Point 2, microservice architectures. Each business capabilities like order, payment service, notification service is a separate service with its own code base and with its own database and with its own deployable or the deployment pipeline. The key benefits like independent scaling, your order service can be scaled to 50 instances during a sales while your user service stay at maybe 1 or 2 instances. You cannot do with the monolithics. So when to choose microservices? Choose microservices when you have a large team, need different parts to scale differently, need technology flexibility per services, or need continuous independent deployment. Point 5, challenges to acknowledge the distributed system complexity, network latency, and eventual consistency, and significantly higher operation overhead. So never start a new small project with a microservices. Let's start with the monolithic, then you gradually convert into microservices. Now let's go to questions 2. How does service discovery work in Spring Cloud? Explain Eureka server and client registrations. So service discovery solves a fundamental problem in dynamic cloud environments, and the answer need to cover both the server setup and the client side. The problem in Kubernetes or the cloud environments like IP changes every time a container registered or the scaled. If we have an hard-coded URL, then it fails immediately in the productions. Point 2, the Eureka server. A Spring Boot application annotated with enable Eureka servers. It is a central registry, a phone book where every server or the service registers its name, host, ports, health check, URL. Point 3, Eureka client registration. So add Spring Cloud Starter Netflix Eureka Cloud dependency. Set the spring.application.name equal to order-services and eureka.client.server URL with the default zone in the application.yml file. So that's the things you need to do for the automatic registrations. Then the service to service call. So instead of IP, you write the services like payment hyphen service and at the rate load balanced on REST templates or at the rate Feign client tells the Spring to resolve the name via Eureka. Point 5, like heartbeat and eviction. Each service needs a heartbeat every 30 seconds. If the Eureka misses the 3 heartbeat, that is 90 seconds, it removes the instance from the registry automatically. So dead instance stop receiving traffic. And that is the service discovery what is covered. Let's move to the question 3, the API gateway. The API gateway, they can ask like what is an API gateway in microservices and what are the key responsibilities. The API gateway is one of the most important component in a microservice architectures. Let me walk through what to actually does in productions. Point 1, the single entry points. The client like mobile, web or the third party never called individual microservices directly. So everything goes through the gateway. It hides you the internal topology completely. Point 2, routing and the load balancing. Routes like API/orders in the order services, API/payments to the payment services, and the distributed load across the multiple instances automatically using the Spring Cloud load balancer. Then point 3 is cross-cutting concerns, JWT validations, rate limiting, course header, request logging, SSL terminations. Handle this once at the gateway, not in every single microservices separately. Point 4 is the Spring Cloud Gateway config. So it's a reactive and a non-blocking running on native. Configure routes in OML with predicates like path, header, methods, and filtered for the transformation and resilience. Then backends for the frontend. In real Deloitte client projects, you often create separate gateway config for the mobile versus web versus any third party API. So different payload size and different rate limit per channel. So that's all with the API gateway. Now questions 4 is about one of the most asked resilience topic like circuit breaker. Explain the circuit breaker patterns and how do you implement it using resilience 4J in the Spring Boot. So circuit breaker patterns is named after like electrical circuit breaker in your home. When there is a fault, it trips and cuts the circuit. The same principle applies here. So why circuit breakers? Without it, when the payment service is down, the order service threads pile up waiting for the response that never comes as the payment service was down. The thread exhausted, order service crash too. That is the cascading failures. Point 2, closed state, normal operations, all calls pass through. The breaker tracks failures in a sliding window. Says like at least for the last 10 calls they will be checking if everything is fine. In the open state, like failure rate crosses the 50%, the breaker strips is open, so all calls immediately return to fallback. There is zero network call made, so this protects the downstream services and free up your threads. Then half open state, after a configure wait, say for example 10 seconds, the breakers allows a limited number of probes call through. If they succeed, then it reset to closed, and if they fail, it go back to open. Point 5 is resilience 4J implementations. So add resilience for Spring Boot annotations and the dependency, and in the annotations you can mention the other circuit breaker and the name of the services, fallback method, and configure the rates and the window size and the durations in the YML file. So let us now cover questions 5, the difference between synchronous and asynchronous communication. So what is the difference between synchronous REST or the Feign versus the asynchronous Kafka communications, and when do you use each? So this is a really good questions about coupling and trade-offs. So let me explain both and then give you the rules when to use what. So in the point 1, the synchronous, which is the REST client or the Feign client, the caller waits for the response before continuing. It is simple and immediate. If you need the results right now, like checking if an user has enough balance before placing an order, then use sync. For point 2, Feign client is a declarative REST client. you define an interface and @Feign client with the service names, add the method matching the API. The Spring generates the implementation by itself. It integrates with the Eureka and Resilience Forge automatically. Then asynchronous, which is the Kafka. Then producer publish an event and moves on immediately. Consumer process it on their own time. So use when the caller does not need the result immediately. Then Kafka decouples completely. When an order is placed, publish an order place event, inventory, notifications, and analytics. Each consumer group receives it independently. Adding a new consumer requires like zero changes to the order services. So the thing is that the Feign for the real-time response when you need like data now, for example payment verification, authentication check. Kafka is for the other things like notification, analytics, order log, inventory, updating, or the email sending. Now the communication pattern is covered. Now in the questions 4, one of the hardest topic is the distributed transactions. So how do you handle distributed transactions across microservices, and why is two-phase commit not recommended? So distributed transactions are genuinely hard. Let me explain why the classic solutions fail and what you actually use in production. Point 1, the two-phase commits block all the participants during the prepare phase. If the coordinator fails in the mid transactions, so every participant is stuck waiting independently. So too slow for the distributed systems. Then SAGA pattern is SAGA is sequence of local transactions. Each service does its own database sites and publish an events or commands to trigger the next step. So no like global lock, no blocking. Then orchestration SAGA, a central orchestration service like an orders orchestration sends the command step by step and track overall state. Step 1 like reserve stock, step 2 create order, step 3 like debit payment. Then compensating the transaction. If step 3 payment failed, the orchestration trigger the compensation in reverse, the cancelling the order service, they restore the stock. The system is consistent against throughout the business logic. So not a database rollback. Then Outbox patterns, write the events to an Outbox table in the same local DB transactions as your business data changes. So Devisium reads the Outbox via change data captures and publish to Kafka. This guarantees like at least once delivery with no distributed transaction. Now the next question 7, how do you manage configuration for 20 plus services without redeploying everything? So what is a Spring Cloud config server and how do you manage environment specific configuration centrally and update it without restarting the services? The point 1, the problem with the 20 services, updating a property means rebuilding, redeploying every services. So config backed into jar is inflexible, slow, risky to change in production. Point 2, the Spring Cloud config service, dedicated Spring Boot service annotated with @enable config server. It reads properties from a Git repository and serves them to every microservices on the startup and on request. Point 3, environment specific files. In the Git repo, you have service name and dev.yml, staging.yml, prod.yml. The activate Spring profile determines which file is served. There is no code changes is required. Then refresh scope and live reload. Annotated beans that should reload with the refresh scope like Actuator / refresh forces those beans to reread config from the config service without restarting the service. Then Spring Cloud Bus broadcast, install the calling Actuator refresh on each 20 instances manually. The Spring Cloud Bus backed by Kafka or RabbitMQ like broadcast the refresh events to all the instances with one single API call. Configuration management is now done. So now we'll move to the security, which is on the question 8. How do you secure the microservices? Explain JWT based authentications and how you secure service to service communication. The security is one of the major concerns. So, and security in microservices has the two layer, like user to service security and the service to service security. Let me walk through you both the cases. Point 1 is JWT, which is stateless user identity. So after login, the auth service issue a signed JWT containing user ID, roles, expiry. The client send it to every request as authentication barrier token. No service side session, completely stateless. Point 2 API gateway validates once. The gateway check the JWT signatures using like auth server public key. This is the only place the auth service is called per request. So downstream services reads claim directly from the token and not there is no network hop. Point 3 the Spring security resource server. Add Spring Boot starter auth resource server, configure the Spring security OAuth resource server JWT, like pointing to a servers. We need to use the pre-authorized and role wise like admin for the on the controller. Point 4 is the service to service security. The service uses OAuth client credential flow, and each service gets its own client ID and secret request and scope tokens, and present it on every outgoing call. Like order services can call the payment, but there is no admin API. Then like TLS and MTLS and the network policy for enterprise security, like Deloitte financial client use MTL via store sidecar injections. Like you will get it into it like once you involve more into the practical details. Now let's move to the questions 9, like how do you actually see what happened in productions. That is, how do you monitor and trace microservices in productions? Explain the Spring Boot Actuator, Micrometer and distributed stressing. Then observability is the difference between like flying blind and the flying with like instruments. So there are the three pillars like matrices, logs, traces. Let me cover all the three. First one is the Spring Boot actuators. So built-in production endpoint like actuator / health give liveness and readiness state for the Kubernetes probes. Actuator / matrices exposes all the applications and JVM matrices. Actuator / info for build metadata. Then point 2 is the micrometer matrix abstractions. Then micrometer is to like matrices with SLF4J is to logging, write the matrices once, counter like timer and plugs it into the backend. Prometheus like Datadog and Watchtowers. These are for the matrix purpose, and there is no code changes required, just we need to have the dependency. Then point 3 is the Prometheus and the Grafana. The Prometheus scraps like the API actuator / Prometheus every 15 seconds. Then Grafana visualize the CPU heap, request rate, error rate, DB connections, pool utilizations. Then see the alerts on like percentage, for example P99, latency and the error rate. In distributed tracing, like Micrometer tracing assign every incoming request a unique trace ID. It propagates via HTTP headers and through all the service hops. In Jenkins or the Grafana tempo, the search by the trace ID, then you can see the entire calls tree with the latency per hop. The structure logging with the trace ID, the inject trace ID into every logs using like MDC mapped diagnostic context. Then you can like grab across the logs of all the 10 services with one trace ID, reconstruct exactly what happened like for the specific user request. Then our last and the final questions is like Kubernetes and on the Docker deployment. How do you deploy and manage microservices using Docker and the Kubernetes. What are the key Kubernetes concepts every microservice developers should know? So every microservice today goes through like Dockers and the Kubernetes before it reaches the productions. So let me walk through the key concept you need to know for the Deloitte environment. So point one is Docker for package consistently. So each microservices has a Docker file. You build an image like Docker build with a command. Then image runs identically on developer laptop. Then with the like CI pipelines and then the production. This eliminates the environment difference completely. Point two is the Kubernetes deployment. At deployment manifest define how many replicas with the image, resource limit, CPU and the memory, and restart policy. The Kubernetes ensure that desired number of pods is always running. Restarting fails once restarting fails like once automatically. Services and ingress. Then Kubernetes services goes every microservices stable internal DNS name, like for example payment service default, some configuration is there. Then ingress controller handles like external traffic routing as SSL like terminations and path based routing to the services. Then config map and the secret, the config map store the non-sensitive config like application properties, features flag, and the secret store like passwords and the tokens on base 64 encoded mounted as an like environment variable or volumes into pods, like never hardcode this in the Docker images. Point 5 is liveness and the readiness props, like liveness props pointing the actuator health liveness API restart pods that and a readiness prop like pointing to slash readiness and removes a pod from load balancer if it is not ready to handle the traffic there is like zero downtime deployment. So that's all what we cover, like 10 Deloitte microservices interview questions. And from microservice architecture we have covered like service discovery to circuit breakers, Kafka, SAGA transaction, config services, JWT security, Prometheus, Kubernetes deployment. These are the like exact topics like Deloitte focuses on the technical rounds. So now you can drop a comments like which question do you think like would show up in your like next interview, and I will reply to your every comments. So if this video helped you on your preparation, so like the video and so that it will be reaching to more Java developers, and subscribe the channel. I post like Java, Spring Boot and interview related questions on every day. So see you on the next video and all the best for your interview.